What are the complete Lewis structure, including valence electrons, of the following compounds? So let's start. So Lewis structure for A, F, H, B, H, O, H, and C, O, N, H. So for this, what we actually do, they've given us quite a big hint because they at least show us how it's bonded, but we have to always make sure that we're counting the right things. So fluorine, okay, is on column 17, but even using the electron configuration, starting from helium, it's 2s2, 2p5, okay? That also supports that because it's on column 17, it has 7, 2 in the 5 valence electrons. Hydrogen, on the other hand, is just 1s1 because it's the first element, and also it's on the first column, so it has 1 valence electron. So in total, we want this Lewis structure to have 8 electrons. So 8 electrons. So to draw that, it doesn't really matter which one you start with, there's only 2. Okay, so we have the F, and it's sharing a bond with hydrogen. So hydrogen has now used up 1 of its 1 electron, so it's good. But fluorine has only used 1 of its 7. So it has 2, 3, 4, 5, 6, 7. And as you see, this fits perfectly the octet rule for fluorine. Fluorine is completely satisfied as well. Hydrogen is done. This right here is your Lewis structure for hydrofluoric acid, okay, FH. Now HOH, we've established that hydrogen is just 1s1, but oxygen is right before fluorine, so using that support as well, 2p4, we can actually verify that oxygen does indeed have just sorry, I'm blanking out a little bit, that we can verify that oxygen just have indeed just 6 electrons. So there's 6 and hydrogen has 1, but there's 2 of them. So in total we have 2 plus 6. So we also need 8 electrons. So for this one, because hydrogen is the only unique one here, we put it in the center. And we're going to put it as this sharing 1 bond each with the hydrogens to the left and the right. Okay. So now hydrogen has shared 1 of its 1, so it's complete. But oxygen, so far, because it's in the center, has shared 2 of its 6. So then we have 3, 4, 5, 6. So this also, oxygen is now complete as octet rule, is completely satisfied. This would be your Lewis structure. And even to verify that as well, we're actually going to get its, I'm trying to remember what that was called. We just talked about it briefly. Should have written a note down. But we're actually going to get the number in terms of the, I guess, to see where the positive and the negative charge are. It's, I guess, theoretical charge. Let's just call it that for now. We have fluorine, okay? It's, like we said, 7 valence electrons. And right now, it has 6 by itself. So it's going to be 7 minus 6. And it's sharing 2. And because it's sharing to divide. And that does equal 0. So fluorine has that theoretical charge of 0. Hydrogen, okay, is going to be 1. And it has 0 by itself. And it's going to be sharing 2. So that also equals 0. We're going to flip it over here. We know how the hydrogen works because it's the same thing. Okay, so still theoretical charge of 0, which is great. And oxygen is going to be 6 now, minus, it has 4 by itself, and it's sharing 4 electrons. So with that being said, this also equals to 0 for the theoretical charge. So everything's looking good because we want to note that because these molecules are neutral, we want to have that theoretical charge as neutral as well, which is what we got. So now ONH, okay, written like this, so thankfully it shows which one is in the center. Typically what happens is that the center molecule is the one that has usually the most space, indicated by being like around like carbon, nitrogen, because those ones have 4 I guess unpaired electrons. Nitrogen has 3 unpaired electrons. So let's just actually break that down. Oxygen, as we discussed, is going to be this 2s2 2p4. That means it has 6 valence electrons, also supported by it being on column 16. Nitrogen is going to be right before it. Okay, so it's 2s2 2p3, also supporting that it has 5 valence electrons, and the hydrogen is just that 1s1, okay, which is going to be 1. So now we have 6 plus 5 plus 1. In total, we need to find a way to share 12. 12 electrons need to be shared. So as it's shown here, nitrogen is in the middle. Okay, we'll start with just a single bond on each side. We have the hydrogen and we have the oxygen. Okay, so with that being said, hydrogen is complete. Oxygen still needs 5 of the 6 because it's only sharing one of them. So it goes 2, 3, 4, 5, 6. So we're done with that. And now nitrogen is right now sharing 2 of its 5. So it needs 3, 4, 5. So with this being said, actually I'll write it down here. I like doing a certain thing. As you notice, we have 1 lone electron on each one, which is why we can then get the electrons to kind of move over here to form a bond with each other. That way, they're both satisfied, still fill the octet rule, and can move on with their lives. So we have now nitrogen, okay, with the hydrogen, and as shown in that picture above where it shows that double bond, this is why when it comes to the Lewis dot diagram. So we have the oxygen, okay, and we have it just like that, and the nitrogen is just like that. And I'm going to make these red to signify where those electrons went. So now this is our Lewis structure for ONH. Don't really know the name of this off the top of my head, but the point being is that when we actually check the numbers now, the theoretical charge numbers, okay, we have hydrogen is still good, 1 minus 0 plus 2 over 2, because that's all it's sharing. Oxygen, okay, it's going to be now 6 minus, it's still going to actually be, has 4 by itself, and it's sharing 4 of them with nitrogen, so it's still going to be 0. And nitrogen, okay, is going to be 5 minus, it has 2 by itself, and it's sharing 6 with the surroundings, which is perfect, because that's exactly what we want. So now we'll be able to see that these are all the Lewis structures with their theoretical charges. All of them are 0 because there's no positive or negative charge, because overall we have a neutral molecule for each one. And there you go. We have the Lewis structure. So we have, yep, I like to draw my bonds even as just the electron dots. So that's why it looks a little bit different. Exactly. We have this as well for the Lewis structure. And then we have that. So with this being said, this is correct. And we're able to even support why these molecules are going to be theoretically, well, they are